Hello guys, welcome to Bugs in Code. The problem that I'm going to explain today is median of the subarrays. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe the channel so that you get notified when I push a new video. So let's get started. Here is the problem statement. Okay, now I want you guys to uh, listen carefully here because the solution to this problem is really tricky to understand, and here I am going to try my best in order to explain everything you need to know about the problem and how we are going to build the intuition. Okay, so let's get started. The problem statement says that you're given an array of n integers and an integer m. The task is to count the number of subarrays which have median m. Fine. Okay, so here it is defined that what exactly is median. So let me explain. Okay, so like if I have an array 1 2 3 4 5, so the size of this array is odd, so in that case middle element is going to be the median. It is the sorted order of the array if you notice after sorting the array. And if the size is even, like 1 2 3 4 5 6, in that case I will have two middle elements, and in those I'm going to return the left one element. Fine. Now one example is given. Let me explain the example. So the example says that, hey, you have an array 2 1 3 5 4 and you are given median as 2. So you basically you have to return all the sub arrays which are having median as 2. Fine. Now if you notice here, then multiple sub arrays are possible for this array. Like I can write either 1 3 or 1 3 5. So a lot of array sub arrays will be created. Like if the size is 5, so 5 into 6 by 2 sub arrays will be created, which is too much. Like this is 3 and 15 sub arrays are possible, but I'm going to write only those sub arrays which will have a median as 2. Like 2 is a sub array which is having median as 2. After that 1 3 2, or like 2 1 3 if I write, so the median of 2 1 3 is going to be 2. If I write in sorted order, 1 2 3 will be there and 2 is the median. Fine. Okay, once one more array sub array is 2 1 3 5. If I write in sorted order, then I will have like 1 2 3 5, and here middle element 2's are this element, and 2 is going to be my output, like left one. Okay, so this is one of the possibility. I have three possibilities here where I have 2 as my median, so I'm going to return 3 as my output. So you can see that 3 is the output here. Fine. Now I hope you guys got the clear understanding of the problem. Now let me talk about the solution. Okay, so I'm going to take the same array as example. Like the array that I have is having elements 2 1 3 5 4, and the median value is 2. Basically I have to return all the sub arrays which are having median as 2. Okay, so if I write the sorted order of this array, then it will be like 2 1 1 2 3 4 5. In this, you let me tell you one thing, that if I'm able to find the count of all these sub arrays which are having median as either 2 or 3 or 4 or 5, and I'm also able to find the count of sub arrays which are having median as either 3, either 4, either 5. So if I subtract this value, like this value from this value, then sub arrays with these values will get cancelled by this. So I will have count of 2 remaining. This means that it is the count of sub arrays which is having like 2 as my median. Fine. So I can generalize this thing. I can generalize it. What I can write is, if I have if I have an array of size n, and I have to find all the sub arrays which are having median as m. So I can first count the sub arrays which are having median as like m or greater than m, like greater than equal to m. Fine. And also I can count the sub arrays which are having median which is greater than equal to m plus 1. That's what we are doing here. Okay, if I subtract this value from this value, then I will get my answer. This is the intuition that is going to be used in order to solve the problem. But one question after looking at this you are going to ask from me. You will say, hey, tell me one thing, that how we are going to achieve this, like how we are going to count the number of sub arrays which will have all the like how we are going to find the number of sub arrays which will have either m or value greater than m as the median. Okay, so let me explain you here. Like counting sub arrays having median having median greater than greater than equal to m. This is the task which we have to do. Fine. I'm going to write the same array again, and I have the array as 2 1 3 5 4, and okay, m is 2 here. Now I want to tell you one thing which is going to be used here. If I have a median, so what is a median? If I count all the values smaller than median like x, let's take x is the count of all the values which are smaller than median, and y is the count of all the values which are greater than median, then for the median I can surely say that either x is going to be equal to y, or my y is going to be equal to x plus 1. Why this condition? Okay, this can be easily understood like the median is at equal distance from the element smaller than x and like smaller than m and greater than m. Fine. But what about this? If I have an array of size m, like odd array, so I will have small here and greater here. So you can see it is one of the examples. You can see that the count of smaller element is less than the count of greater element, because we are choosing the element left from the middle. Fine. So that's why I have written these two conditions. Now if I write the difference is 0 here and difference is 1 here. Difference between greater element and the smaller element is 0 in this case and 1 in this case. Why I need this? You can notice at any point in time that we are not interested in the count of element, greater and smaller element. Instead I'm interested in the count, like how many element, what is the difference between these elements, because if the difference is 0 then median, or the difference is 1 then median, else it is not a median. Fine, let's keep this. This is going to be used later, but for now, moving back to this, I want to tell you one thing, that any subarray that I choose from this array is either going to end at this index, or 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 at this index, isn't it? Like if I write any of this subarray, then it is going to be end at any of these index possible. Fine. So for every index, like for every element in the array, I am going to count the number of subarrays which are ending at the current index and having median greater than equal to m. I want to listen carefully here. For every array index, I am going to count the number of subarrays which are having median greater than equal to m and which are ending at the current index. So let's keep track of this by a variable which is total. So I have a variable total here. Total variable will keep the count of for current index, it is giving me the count of all the subarrays which are having median greater than equal to m. So let's take the count is a here, b here, c here, d here, e here. Then what we have to return is a plus b plus c plus d plus e, isn't it? This value is something which we have to return. So it is basically the sum of total I. Like for every index, I am just counting what is the value of total for this index, for this index, for this index. This is what we have to do. Fine. Now one thing that I have observed till now is I am going to write something like, for each array element, what I can do, for each array element I can just do something like answer equal to answer plus total. Till now we have figured out this thing, and at the end I am going to return my answer. Fine. After that, if I have the array, let me write the array again, 2 1 5 3 4. Okay, in this array I am going to categorize element into two parts. Either element like ai is greater than equal to m, or ai is smaller than m. I hope you guys don't have any doubt in this. Like any element can be either greater than equal to m or smaller than m. Fine. Any element greater than m, I am going to represent it as 1. And any element smaller than 1, I am going to represent it at -1. Even it doesn't matter. Why it doesn't matter? Let me tell you. I'm just interested in the count of greater and smaller element. Even I'm interested in the difference. So why to bother like what is the value here? So I'm going to represent all the value greater as 1 and all the value as smaller as minus 1. But this is something which is going to give me profit. Like each at any point, if I count all these elements, then this is going to give me the difference. Like if I count all the element like 1 1 1 minus 1 minus 1, then it is going to give me 0, which means that the difference between greater and smaller element is 0. And even if you write I have 2 greater element and 3 smaller element, then it will be like 2 minus 3. So you can see that it is minus 1. Minus 1 means that the number of smaller element is greater than the number of greater element. So you can see that. Now one more thing that we have to do is, from here you can figure out that I have to keep track of sum of like x and y. I have to keep sum of x actually. Let me tell you. For this, let me give you a basic dry run. Like for this value is something which is greater than like m, which is greater than equal to m. So I'm going to like 1 here. After that this is smaller, so I'm going to write minus 1 here. If I add these two values, then I will get difference as 0, which says that the number of element greater and smaller are equal till now. And you can even see that after that if I see 5, then it will again add 1, so it will become 1, which means that the number of greater element is 1 more than the number of smaller element. You can even see here. So this is why I am going to take a variable current as 0, and this current is the sum of these 1 and minus 1. How to write this 1 and minus 1? I will have a variable var equals to, I will check if ai is greater than equal to m question mark, then it is going to be like equal to 1, else it is going to be equal to minus 1. Here I am basically using the conditional operator, so I will have x variable here where x is equal to this, fine. And after that I have to do each time current equal to current plus x. I hope you guys are clear with this line and this line. Here this current variable is basically to like I don't know how to explain this, but I just want to tell you that each point this current variable is to tell you that how many, like what is the difference between the number of greater element and smaller element at each point in time, fine. After that I have to do one thing. If my x is double equal to minus 1, this means that the current element is smaller, then I have to do something, and else I have to do something. Now this is very important. Why this is important? Let me first of all I am going to write what we have to do. After that I will tell you why we are doing this. So first of all, one thing is sure that my total is going to change here. Why? Because each time we are changing the total, and when we move to another index, then the total is something which is storing the number of subarrays which are ending at this index. So like in the previous iteration it was storing for this, now it has to store for this, so total is going to change. How total is going to change? Total equal to total plus map of current minus 1, and here it is going to be okay, total minus map of current minus 1, and here total plus map of current. I will tell you why we are doing this. For this time just accept this, like we are doing this, okay, it is fine. Now am I left with anything else? Okay, I'm not left with anything else. I will tell you what else we can do here, but for this time let me explain you this part. Okay, fine. So we have a very important part to understand, like how total is going to change if the current like value is greater or smaller than the like median. If I have 2 1 like 3 5 4 and I'm at this point, you can see that the element is something which is greater than median. So for this x is going to be equal to 1. Okay, so now at this point what I have to do, let me tell you one thing first. My current total is storing the count of subarrays which are having which are ending at this particular index and which are having median which is greater than equal to m, fine. So for this let me write those subarrays. One can be like 3 itself and the second can be 2 1 3. You can even observe that the median for this is 3 and for this is 2. So now I can append this 5 to any of these. Like if I write 5 here, So again I am going to have median which is greater than or equal to 3, and even if I write 5 here, then again it is going to have median greater than or equal to 3. Means whatever total value I have here, in any of that value I can append this 5 and I am going to have median again greater. So my answer will be at least total. Like my answer, whatever is my total, will be at least remain total, or it will be something like total plus something else. But what is this? What is this? What I have, what I can add here? I'm going to explain like 2 1 3 5. This is really tricky to understand. After I explain you guys, I want you guys to keep dry run of this, how it is working. If I'm at this particular place, so till here I can see that I have two greater element and one smaller element than 2. 2 is my median here. So like this and this are greater than or equal to, and this is smaller, so I can write this. After that, if I see at this, so I have one greater element and 0 smaller element. So you can see that the difference is 1 here and the difference is 1 here. So two times we have found the same difference, and this means that if I remove this part from the array, then I am going to have, again I am going to have an array which will have median greater than or equal to m. So I can 5 as my sub array. Fine. But if I don't remove this part, instead I remove this part. This is what these index are giving me. If I remove this part, so I will have 135 as my sub array, and 135 is again the sub array which is having 2 as which is having median greater than or equal to m. Fine. So this means that what is the count, like how many times we have the difference like we have this difference. So this is going to be like coming from a map which is storing the difference. So now I hope you guys are clear with what map is actually doing. Map is storing the count of like, I will say cur here because cur is something which is storing the difference between smaller an element y and x. Cur is the variable which is storing, so I need to like store this cur. So if I write if I show you this pseudocode, in this pseudocode you can do something, you can have a map here. So okay, let me show you this full thing. Fine. Now I'm going to have a map here, and in this map I will add every time cur element. Okay, fine. Like how many times the current occurs, this is what I'm doing. And initially I will store the current situation, like for 0 I will store map of 0 plus equal to 1. Why I am doing this? Because 0 greater element and 0 smaller element is a condition in itself. Like if I have 0 smaller and 0 greater till now, and I add 1 greater element, then this is a condition. Okay, fine. So that's why I'm doing this. Now this is the whole pseudocode, and I'm just going to explain the other part as well. Now I hope you guys are clear with one part. So one part is basically showing you, okay, it is really hard to navigate in this. Okay, so I will write map of current here. So this is what we have to add when my value is something which is 1. Else if my value is double equal to -1, this means that I have found an element which is smaller. So let me explain you this condition as well. I have total here, total till this index. So I have like sub arrays like 3 itself and 2 1 3. These are the sub array ending at like this index and having median greater, okay, or equal to. Okay, so if let's say if this element is 0, because I'm considering the case where element is smaller than m. Fine. So for this element 0, this 0 can either append at this or append at this. So when this 0 append at any of these places, then this 0 just destroy something. It destroy the condition where I was having median greater. So now the median of this is smaller than equal to m. So now I have to subtract something from total, I mean total will be equal to total minus something. But how many times I have to subtract? So I can see that I have 0, like I have 2 greater element here I have 2 greater element and 1 smaller element, and the difference is 1. Fine. So I can see that I can see that like how many times it is going to subtract. It is going to subtract how many times this value occurs. Like here one more smaller element is going to add, so now the condition will become 2 greater and 2 smaller element that I have. So how many times this condition occurs, these many times it is going to subtract from total. So when I add this, what is the meaning of adding this smaller element? I'm basically doing current minus 1, because minus 1 for adding new element, because every element every smaller element represents a minus 1. So I'm going to find how many times current minus 1 is occurring in my array. So these are the conditions that I have written in that code. So you can even see now that this is the code which is going to count how many subarrays are possible. Okay, like I hope you guys are clear now. Let me try to navigate this. It is really hard to navigate, so let me just move to the code, because okay, so okay, I have not opened the code yet, so let me show you the code. Here I have the folder which is containing the code. So what I'm going to do is, okay, I have not explained the brute force approach, because if I explain the brute force then it is going to take a lot of time, but actually the brute force is quite simple. So I will open my notepad here now and let me show you the code. Okay, so this is the C++ code, and I'm going to show you one more code which is the Java code. So let me just take some time to like settle this thing. Okay, so I have Java and C++ code as well. So now here you can see, here I have Java code and here I have C++ code, and you can see that what I'm doing, this hash map is basically to keep count of track of the current that we have. Now I have explained all the things like what is current, what is total, what is answer, and here I'm just going to show you the code, and you can observe that the code is like very similar to the thing that I have explained you in the like explanation. Fine, you can see that I'm putting my current in the map here. In Java, this is how we use map, and this is for C++. I'm using unordered map. So each time I'm adding value which is total for my answer. So it is basically calculating for every possible index. And you can see very important thing here. Like, let me write this thing in a better way. So what I can do is, I have first value as this. So from this value, like, okay, so I have this value, and I can return something which is this value minus this value. Now it will be more clear to you. Like, this is what I have explained you in the starting of video, like how do we get this intuition. After that we are just calculating for this. Implementation looks very simple, but it is really tricky to understand. Now I hope you guys are clear with the problem, like how it is going to be solved. And so this is all about this video. Thank you.